Welcome to RF lecture series. In this lecture, we'll discuss about the power amplifier. Power amplifier. A radio frequency amplifier is a tuned amplifier that amplifies high frequency signals used in radio communications. So what is the purpose of using the power amplifier is we have to amplify a signal as much as high in the transmitter block. So when it reaches the receiver block should detect our signals. So in the transmitter block, after the oscillator, a signal may get attenuated due to the external environment. So this RF power amplifier will improve the input signal so that the receiver can be able to detect the signal. So here the frequency at which the maximum gains occurs in the RF amplifier is made variables by changing the inductance or capacitance of the tuned device. So an RF amplifier can tune over the desired range of input frequencies. The power gain of RF amplifier is always limited to at high frequency. So next we'll see where the power amplifier is located. So here now let's see where the power amplifier is located. So here we can see recall the transmitter block, and here you can observe this power amplifier is placed before the antenna, and here this power amplifier signal amplitude will be less. So after attenuating, so what this power amplifier block will do is it amplifies this power, that is it increase the amplitude level of the signal. For example, this high power of power amplifier will be the 1 watt. For example, like GPS or something, the power amplifier sometimes it will be of 0.2 to 0.5 watt. It will vary from 0.2 to 0.5 watt. So next we'll see what are the goals, that is what are the parameters will be in the power amplifier. Now we'll see this how this RF power amplifier drives the antenna of the transmitter. Here you can see this block, and here I'll show this entire region is an power amplifier. Let us consider we have placed an filter. There is a filter placed between this power amplifier and an antenna. So let us observe the case. This, if we are directly feeding from output of this power amplifier directly to this antenna, means there will be the problem of the matching. So here, for example, let us consider the power amplifier. So here, if you are getting directly output of this, so here, if you see this, the outside of this thing, antenna is feeding is we call as Pout. So we are not directly feeding out of this output of this power amplifier to this antenna, because this antenna impedance will, let us consider if it is of 50 ohms of impedance, and if you are not getting the same power, will not be impedance will not be from the output of this power amplifier. So that's why we have placed an intermediate block of filter here. So what this filter will do is, this filter will attenuate, that is it will attenuate the external signal, and this filter will act as an impedance matching. This what is the output of this amplifier, and when it is feeding this, it will feed that is power, which is what is the amount of impedance is required, it will directly feed to this antenna. Let us consider it's nothing but we'll have this optimum amount of impedance. So based on this what antenna is required. For example, if it is 50 ohms, so what this filter will do is, based on this, it will change this output, and then that is it will optimize the impedance, and then it will match with the antenna, so that we can able to transmit the signal. So there are some desired parameters. Here we can see one is first is a gain. So gain is nothing but P out by P in. That is what when it reaches the receiver, that amplifier power, we have to get this. Next, the power output power. Here already we have seen this. Let us consider if we are having the high gain power of 1 watt, or else it will be of 40 watts. So based on the distance between the transmitter and the receiver, based on the distance, that power will get vary. And next is the bandwidth, and here we'll have the two types of bandwidth we'll achieve. Either it is of narrow bandwidth or else it is of wide bandwidth. So in narrow bandwidth we'll get only the desired frequency. For example, if it is of Bluetooth frequency of, then bandwidth frequency will be of 2.4 frequency. So here, instead of going this narrow bandwidth of desired one particular signal, we'll focus on this bandwidth of this band of frequency, multiple band of frequency. And next is the power efficiency. This power efficiency is it's an important parameter, that is of power delivered. That is, I'll denote as power delivered as in PD, divided into this power dissipated. Power dissipated, DIS will I'll keep as DIS for dissipating this power. So when it reaches the receiver, we have to see the power, how much power has been dissipated. So let us consider. So I'll draw this that power amplifier. This is the source, and here if it is considered as an in, this is the PA power amplifier block, and here this is the input. And if you're feeding, and here we'll have the source. That source will be of VDD, and this is the power output. And here in this case, if you see this power amplifier, the power dissipation is nothing but how much amount of power has been used by this power amplifier, and what will be the output. So what this power amplifier will do is, like, power amplifier will pull the power from the source. That is nothing but VDD into IDC. We know this, like a basic thing, VDD into IDC. So what this power dissipation will be, this power dissipated will be equal to power input, that is of nothing but voltage source, VD into IDC. So here this when this power output will power delivered will is high, that power dissipation level be the low. So next the linearity. So we will not discuss about the linearity. And next is an input and output matching. We are using the amplifier. They will have the different stages of amplifier, like from one stage 1 to stage 1, based on this divider and how many stages we are going to use. So for in large array case, we'll have the different types of stages will be there. If you are going for large number of array cases, we'll have the power divider will be in the different stages. So in that case, from when the power is dividing from one stage to other stage, we have to see what is a proper matching between the input and output inputs. So already we have told that there here you can see there should be the optimum, that is matching between this input and power amplifier. Similar to this, this should be the proper matching. Then only we can will have the result. Heat dissipation. So we have to be very careful while designing this amplifier or power amplifier types. There are different types of power amplifier which we call as in modes or different classes. So there are different classes like class A, class B, and class C. So there is a combination of class A and class B also as well. So here this class A, B, and class C we called as an linear power amplifiers. So in that high power, then we go for this class E and class F. So based on this classification, like how we need, either it is of low power or high power, this we can able to take this which type of this amplifier will be suited for us. And we'll not discuss about this class D, because class D will work in the low frequency only. So and here you can see this is an one stage amplifier, and this transistor, and you can see this transistor is not directly connected to the input and output. And here there is an matching network, input matching network, and then output transistor is 50 ohm. So we'll not get directly of 50 from this to this transistor. So this impedance of this transistor also will get vary. So we need a proper matching network that we call as a Z output, that is of impedance of optimum impedance. And similarly we'll have the optimum of input matching set at the input matching network also, because directly getting 50, so this chances impedance of this transistor also will not get matched. So there should be the proper matching between this input side also and output side also to reach to get this what is the actually required our value. That is the main thing we have to see when we are designing this amplifier. So this matching network is also placing a major role when we are designing this. That it should be very properly designed. Then only we can able to get the desired output. So with this, we'll conclude that we have covered all the blocks, and in next series we'll see about microwave amplifier, microwave, how we use the microwave thing. So I have covered all the basics of transmitter and receiver blocks. Thank you.